Hello everyone, welcome to Learning with Friends. In today's video, we'll discuss 5 important GMAT problems from geometry. These 5 questions are in increasing order of difficulty and we recommend that you try them on your own before you look at our detailed solutions. While they are targeted at GMAT students, these questions and the concepts they involve are important for other exams like GRE, CAT, SAT, ACT and others. So the first GMAT question that we'll see is given on the screen. Let's read the question. The lengths of the sides of a triangle are x, 4 and 6, where x is the shortest side. If x is an integer, which of the following is a possible value of x? And we are given 5 options, A, B, C, D and E, with 5 values ranging from 1 to 5. So we need to find out what is the possible value of x. Now, the sides of the triangle are given to us as x, 4 and 6, and we have to figure out the value of x with the condition that x should be the shortest side. So if this was my triangle, just a very rough figure, then the shortest side is x, right? So how do we go about it? Let's look at the first option, option A, which is 1. So if 1, 4 and 6 were the possible values, now such a triangle with the values of 1, 4 and 6 cannot exist, because there is a triangle property that says that the sum of any two sides of a triangle should be greater than the third side of the triangle. So if that is the case, then you notice here that the sum of 1 plus 4, this sum is 5, which is definitely not greater than 6, right? Therefore 1 cannot be the third side. 1 is the wrong option. Let's look at 2. If I take 2 as a shortest side and my triangle is 2, 4 and 6, this triangle is also not possible, because 2 plus 4 is 6 and 6 is equal to 6, while the condition is that the sum should be greater than the third side. So this also is incorrect. Let's look at 3. Now if my triangle was 3, 4 and 6, now here 4 plus 3 is 7, which is certainly greater than 6. So that condition is satisfied. Also, if x is 3, then 3 will be the shortest side of this triangle, because 3 is less than both 4 and 6. So right now 3 looks like the best answer. So for now we can keep 3 as an answer. Let's also look at 4 and 5. Now if we took 4, then my triangle would be 4, 4 and 6. Here the sum of the two sides is 8, which is greater than 6, so that is fine. But a 4, 4, 6 triangle would be an isosceles triangle, like this, where this side is equal to this side. And this is not the shortest side then, because we wanted x to be the shortest side. So therefore 4 cannot be the answer, and for the same reason 5 cannot be the answer, because if we take 5, 4 and 6, then again 5 is not the shortest side. The shortest side in this triangle is 4. Therefore 5 cannot be the answer. So therefore our right answer is option C, 3. So let's look at the next GMAT problem. Sarah is making a gift item for her son's birthday party that will involve fitting a hollow paper cone inside a plastic pipe as shown below. So if you can see this figure, there is a cone here, right here. I'm just going to mark the cone just for your, this is the cone that we are talking about. Made a very rough sketch. and this cone is inside the plastic pipe, the big one, the solid figure which is shown outside. Now the diameter of the pipe is given as 6, which means this distance is given to us as 6 from this point. This distance is given to us as 6 till here. This diameter is 6 and the height is 4, which means this distance, this height is 4. Right. What is the surface area of the cone? So the blue margin that I had shown, the cone, that surface area we have to find out. Now the surface area of any cone is given by the formula pi times r times L, where pi is the figure pi, 22 by 7, r is the radius. So the radius of the cone will be half the diameter. So the radius will be half of the diameter, and the diameter of the pipe and the cone are the same, as you can see in the figure. So the radius will be 6 by 2, which is 3. And the slant height is this. In any cone, the slant height is this figure, this value. So if you notice, if I were to consider this triangle, then in this triangle we have a Pythagorean triplet where L is the hypotenuse, this H is one of the sides, and the radius R is the third side. So in this triangle, by Pythagoras theorem, L squared should be R squared plus H squared. We know that radius is 3, we just calculated that, so 3 squared, and height is given to us as 4, so 4 squared. You can actually solve this. You'll get this as 16 plus 9, 25, which makes L square root of 25, which is 5. Ideally you should not need to solve this because 3, 4, 5 is a common Pythagorean triplet. So the moment you know that 3 and 4 are the sides, your hypotenuse is 5. So that's it. We just have to calculate the surface area now. So the surface area of the cone would be pi, r is 3, and L we just calculated 5, so that becomes 15 pi square units, which is option E. So that's our right answer. So let's look at the next question. It says, at how many points does the straight line y is equal to 9x plus 2 meet the parabola y equal to 2x squared minus 7x plus 34? Now in general, not just particular to this question, if this were my coordinate axis and this was my parabola, right, just a rough sketch again, then it's possible that this straight line cuts the parabola at 2 points. So one point is here and the other point is here, right? So it's possible to have 2 points of intersection. So I need to look out whether 2 could be my answer. It could also be possible that if this is my parabola, then the straight line just doesn't cut it at all. It just passes by somewhere else. So 0 could be a possible answer. And it is also possible that if this is my parabola, then this straight line is a tangent to the parabola. So it just touches the parabola. Again, a rough figure. Right? It could be a tangent at any point. It could be a tangent here. It could be a tangent here at any point. So I'm just giving you different scenarios. So even 1 could be our answer, right? So basically it could be one of these 3 scenarios, right? 3 and infinitely many is not really possible for a straight line and a parabola. So therefore we have to figure out which of the first 3 options could be the right answer, whether it's 2 points, whether it's 0 points, or whether it's 1 point as in a tangent. Now for that it's pretty straightforward. You just solve these two equations. The first equation is the straight line equation and the second equation is the parabola equation as simultaneous equations. So you just equate the y components of both. So you have 2x square minus 7x plus 34. Let this be equal to 9x plus 2. Because the point at which they intersect, the two equations have to be the same because those points satisfy both equations. So we bring all the elements to one side. So 2x squared remains 2x squared. When we bring 9x here, it becomes minus 9x. Minus 7 minus 9 becomes minus 16x. And when you bring 2 here, it becomes minus 2. So plus 34 minus 2 is plus 32. There are every factor here, every term here is a factor of 2. So we can divide this whole equation by 2. So that this becomes x squared minus 8x plus 16 is equal to 0. Now you can either split the middle term, right, which is what we normally do for a quadratic equation, or you can see that we have a perfect square here, 16, right? So this fulfills x squared minus 2x into 4 plus 4 square. This equation is of the form a square minus 2ab plus b square, which is the formula for a minus b whole squared, right? So what am I saying here? A square minus 2ab plus b square. This is what the form is. This is the formula for a minus b the whole squared. So this equation is in that form. So we notice that it is x minus 4 the whole squared is 0. If this was my coordinate axis and if this was 0.4 and I'm following a different scale on the y-axis and this is 0.38, and if this is 0.4 comma 38, right, and if my parabola passes through it, right, a very rough figure, then my line will also pass through this point, right? Again, a very rough figure, guys, but what I'm trying to say is that it's a tangent at this point because we've got two equal values for x. We basically, when you say x minus 4 whole squared is equal to 0, what you're typically saying is that x takes the same value. That is what we mean when we say that x minus 4 whole squared is 0. It's not that x takes just one value, it means that x takes the same value repeatedly. So therefore there is a tangent at that point, right? And that is what we are trying to represent here. So therefore my answer to the question that how many points will the parabola and the line meet is 1. So that's the right answer. So let's look at the next question. The two circles below are concentric, that is they have the same center. So this is the center O that is shown here. The length of the chord tangent to the smaller circle, this chord which is shown here, is 16 millimeters. What is the area of the ring between the two circles, right? So this entire shaded area is what we have to find out. Now in general, what is the area of a circle? The area of a circle is given by pi times r squared, where r is the radius of the circle. So if I have to find the area of the shaded area between the two, let's say that in the big area, the big radius is capital R, the big circle, and the small radius is small r for the small circle. So the area of the shaded region will be area of the shaded region will be the area of the big circle minus the area of the small circle, which is pi times capital R squared minus pi times small r squared. So basically we have to find this value. The problem is that we are given neither capital R nor small r. What we are given is the tangent chord length, which is 16 mm. There's an interesting fact that we can use here. If I were to join the center to this point, then this is obviously capital R because this is the radius of the big circle. And if I were to join this center to this point, with, as per the rule of circles, a line drawn, the radius drawn from the center to the tangent is perpendicular, then this will be small r because this is the radius of the smaller circle. So we notice that if this was point A and if this right here is point B, then we notice that triangle OBA is a right angle triangle at point B. Also, for the outer circle, a perpendicular drawn from the center would bisect the tangent, which is here the chord, which means that the distance AB will be half of the length of the chord, which is 16, so that will be 8. Right, so if remember that ultimately we don't need individual values of capital R and small r, we just need to find this particular value, right? And I think with this information we can do that. So if we were to apply Pythagoras theorem in the triangle, what triangle are we looking at? Triangle OBA, which is a right angle triangle, and we are applying the Pythagoras theorem here. Then capital R squared would be small r squared, because capital R is the hypotenuse, is equal to small r squared plus AB squared, because these are the two smaller sides. Now AB we just saw is 8. So if I were to take small r here, then capital R squared minus small r squared would be 8 squared, which is 64. And if you notice, this is exactly what we needed, because the area of the shaded region is pi times, if I take pi common from both of these terms, pi times capital R squared minus small r squared. So that will be 64 times pi. And that means my right answer for this question is option C. So interesting thing here is, you just have to not worry about finding the individual values, because what you need can be found just by knowing the length of the tangent to the smaller circle, which is the chord for the outer circle. So the right answer is C. Okay, and let's do the final question. In the coordinate plane, lines L and M are parallel. So this line and this line, these two are parallel lines. The area of triangle OCD, the area of this triangle OCD is 1/4 the area of triangle OAB. So this triangle. So triangle OCD area is 1/4 triangle OAB, right? What is the area of triangle ABC? So ABC is not completely drawn here. We can just draw ABC, a rough sketch. So triangle ABC, if I were to just complete the triangle, yeah, so this triangle ABC is what we need to find the area. Now these two lines are parallel. Now a property of parallel lines is, so if I were to just draw these lines like this here, and if this was my chord or line CB, then this angle will be equal to this angle, interior opposite angles, right? Also, this is coordinate axis, so this angle is 90 and this angle is also 90. And for the same reason, if this was my parallel lines, and this is point D here and this is point A here, So again, this angle will be equal to this angle. So we notice that all the three angles, angle O, which is a common angle, angle C, which is equal to angle B, and angle D, which is equal to angle A, which means that triangle OCD is similar to triangle OBA. Why am I writing it as OBA this time? Because C is similar to B and D is similar to A. So just so that there's no confusion, I'm writing the corresponding points. So if two triangles are similar, then what do we know about the ratio of the areas? The ratio of areas of two similar triangles is the square of the ratio of their sides, right? So this is a property of similar triangles, that the ratio of the areas of two similar triangles is the square of the ratio of their sides. So we were told that the area of triangle OAB is 4 times the area of triangle OCD. Therefore, OA, which is the side of this triangle, will be twice, right? Because it will obviously have to be the square root of 4, will be twice OD. Correspondingly, OB will be twice OC, and AB will be twice CD. Right? So this is something that we can gather from the property of similar triangles. Which means what? If this point is minus 6, 0, what does that tell us? That means this distance from D to O is 6. So OA will be double that. And because this is the positive x-axis, point A will be 12, 0, obviously, because the distance is double, so it is 12. Similarly, if this is 0, 4, that tells us that this distance from C to O is 4. So OB will be double that, but because this is negative y-axis, point B will be 0, minus 8. Why are we doing these calculations? Because we need to find the area of triangle ABC. Now, area of triangle ABC. Area of any triangle is half times base times height. So if I were to just put this triangle like this, so right now it's horizontal, I'm just writing it as vertical, putting it vertical. So this is A, this is B, and this is C. So then this becomes my base, BC becomes my base, and AO becomes my height. This is point O, AO becomes my height. Now what is BC? If you notice, BO is 8 units, OC is 4 units. So BC total, this would be 8 plus 4, 12 units. And AO is just 12 because from point O to point A, the distance is 12. So AO, this distance is just 12. So my value becomes half multiplied by 12 because base is 12, height is 12. I cancel 2, 6 is 12, and 12, 6 is 72. So my area of triangle ABC is 72 square units. So that's how we solve this question. That's all for now, friends. If you like this video, please hit like and share it with your friends. Also subscribe to our channel Learning with Friends. Let us know in the comment section what other math videos you'd like us to make in future. Bye for now.